Okay, so, all right, anyway, all right, so here we go. He came here from New York City, hating the weather. This is beautiful, right? Yeah. Palm Springs, about time. And so he used to be a fine arts major and realized he loved mathematics. He used to work in the woods helping kids with wilderness survival techniques. And then he realized math is awesome and came back to teaching math. He's got a master's in math ed, he's part of MFA New York. So any MFA people out there? Not New Yorkers, but yeah! So here are his 2 truths and a lie. This is a mouthful, number 1. My wife and I decided to write our own wedding vows while recovering from his bachelor party the night before. I realized I still needed to write them, so we relied on one of those beautiful things you can think of on the fly without having the opportunity to write it down, and that was Euler's equation. Or, my wife has Euler's equation tattooed on her knuckle. Or, he can juggle torches as a side job on weekends as an entertainer. So let's hear what Blue has to say.
I just want to say, I want to give you a warning. I know Brian, before we start this, I know Brian said that anytime a speaker makes a mess or a slip, whatever, you should take a drink. Don't do that with me. Because then you'll all be under the table. One of the most exciting things that can happen in a math class is when a student makes a connection. I think that math is all about making connections. Otherwise, what's the point? I remember when I was an undergrad, that was, yesterday. When I was an undergrad, in my differential equations class, the professor, a few weeks into the course, was stressed, saying we needed to move a lot quicker. So then he picked up the marker in one hand and the eraser in the other. They didn't put either down for the rest of the class. And he furiously wrote down theorems, lemmas, correlations, equations. My friend and I were furiously trying to keep up, write down all the notes we possibly could, not comprehending anything. And going at breakneck speed. It honestly reminded me, it was like the mathematical version of the Karate Kid. It was like, right, erase, right, erase, wax on, wax off. So, how much do you think was covered in that class? A lot, but no connections. So a few years ago, in the New York Times, an article appeared, "Is algebra necessary?" The author tried to make a case against mandatory mathematics education. Ouch. Saying that it is demoralizing for students and mostly not applicable to their future. Sadly, I think many adults come away from mathematics classes thinking that it is nothing but disconnected, random topics and tricks that don't really have any meaning on their real life and only regurgitate it for test time and that's it. And I think sadly, a lot of teachers, it's easy for us to fall into the trap of thinking that it's this huge checklist that we need to get through by the end of the year, and we've done our job if we've managed to get through this entire checklist before the year is over. But if this is the case, how much actual thinking happens? I think that math is more than a checklist. I think math is a beautiful way to help see reality. And I think it is an opportunity to both be creative and analytical at the same time. That's awesome. So, I'm going to give an example of what I think is one thing about making a connection. Doing and undoing. Multiplication can undo division. Addition and subtraction can undo each other, just as some functions can undo other functions. So it's a powerful connection, I think. So how can we help students to be thinkers and make these connections rather than treating them like boxes to be filled with random, disconnected topics? I think that one thing we can do is to help them with these connections. Phil Darrow, one of the main, you guys might have heard of him, one of the main Common Core authors. Anyway, he asked this question, how can I use this problem to teach the mathematics of this unit? I think another way to think of this is, how can I use this problem to help students understand the connections within this unit? So I propose that we try to teach, to help with these big ideas, that we try to teach to the big ideas within the units and help students to grasp and grapple and struggle, work hard with the effort with the biggest ideas and connections possible. And here's an example of maybe one big idea that I would try to have students come away with in linear equations. So when we focus on the connections and we can let go of these checklists, I think it allows us a breath of fresh air and freedom to go deeper, to have bigger, richer tasks that can be more meaningful, maybe over the span of days, and students are equipped to pick up the little details on their own, because they actually have more comprehension and connections. Also, when we focus on the connections and the big ideas, this can increase retention. Studies have shown that when things are connected in our minds, we're more likely to retain them, especially when new information and old information. When we focus on teaching to the big ideas and the connections that students can make, I think this also promotes teacher collaboration, and it can be used as a tool for that because we can focus on those big ideas and connections and not worry about the little details so long as the students can at least get the big picture of things. I think it's important that we focus on building the mathematical foundation. Please do not confuse this with disconnected topics. That's not what it is. This is about the big ideas and those connections. So I'm hoping that we can have a paradigm shift and move away from worrying about like the paint color or whatever and installing which windows to install and all those random details and focus on the foundation. Back to the Karate Kid, math class, linear equations. I think maybe, I'm just going to give an example of something you could have done. Maybe you could have worked in individual groups. We could have each generated our own proof of different theorems or a situation, and then we could have combined together and discussed each other's theorems or something. Anyway, this last slide is just my shout out to thank everyone that has helped me make connections in my life about math. And it's also, I know this is going to sound cheesy, but I totally mean it. I don't think it's just the connections we make in math, but the connections that we make with each other. So I want to thank all the students, professors, teachers, and awesome people that make me math.
Okay, so blue, which is it? The vows, the wife's tattoo on her knuckle, or you can juggle torches?
That's kind of hard to answer now after the bumper sticker thing, but I can juggle clubs, but I'm probably too scared to do torches. All right, thank you.
All right.